Hello students, welcome to Eduauraa. Myself Professor Paras Tanna, your physics mentor. Today we are solving MCQs from the chapter Simple Harmonic Motion. A particle is executing simple harmonic motion with a time period capital T. At time t is equals to 0, it is at the position of equilibrium. That means the particle is starting from mean position. The kinetic energy time graph of the particle will look like. The four options are actually given in terms of graphical module. This MCQ came in JEE Main's 2017 examination. Students, to solve this particular question, we are going to use the basic formula of kinetic energy of a particle which is performing simple harmonic motion. The formula of kinetic energy goes like this. Ke is equals to half into mass multiplied by square of velocity. Now students, half m we can keep as it is multiplied by square of velocity. That means v is equals to omega a times of cos of omega t. The whole square will remain as it is. Students, over here it is provided that the particle is starting from extreme position. As I told you students, the given behavior should be square cosine function. But we can also check this. Let's say at time t is equals to 0, omega t will give us 0. And the formula contains cos. So students, cos of omega t will be actually cos of 0. And what is the value of cos 0, students? It is 1. So cos of omega t is equals to 1. And that's why at t is equals to 0, kinetic energy will be maximum. Second time, students, when time is equals to 1/4 of time period, that means small t is equals to t by 4, the value of omega t will be pi by 2. And students, cos of omega t this time will be cos of pi by 2. And what is the value of cos pi by 2? It is 0. So when cos of omega t will be 0, we can say that kinetic energy will also be 0. Next time, students, when time is, let's say, half of time period, that means t by 2, we can say that omega t will be equals to pi, students. And when omega t is equals to pi, the value of cos of omega t will be equals to cos of pi. And students, what is the value of cos pi? Yes, it is -1. So this time also, students, the kinetic energy of the particle will be maximum. So at small t is equals to half of time period, kinetic energy will be maximum. Next time, students, when time is, let's say, is equals to time period, the value of omega t will be equals to 2 pi. And students, when omega t is equals to 2 pi, the value of cos omega t will be equals to cos of 2 pi. The value of cos 2 pi is 1. That is the reason, students, this time the kinetic energy will be maximum. So when time is equals to time period, kinetic energy of the particle will be maximum. Now students, observe the given graph in option B carefully. When we do that, students, we note that when time is 0, kinetic energy will be maximum. When time is equals to 1/4 of time period, kinetic energy will be 0. Now students, we look at the graph given in option B carefully. When we do that, we note that when value of time is 0, kinetic energy will be maximum. When time is equals to 1/4 of time period, at that time kinetic energy will be 0. Next, when time is equals to half of time period, that is t by 2, kinetic energy will be maximum. Then at time is equals to time period, we say that kinetic energy will be 0. That is the reason, students, I told you that the given graph should be a square cosine function, and that's why with confidence now we can say that the answer is option B. Next MCQ, students. A particle performs simple harmonic motion with amplitude A. its speed is tripled at the instant at a distance 2a by 3 times from the equilibrium position, that is mean position. The new amplitude of the motion is, your options are option A 7a by 3, option B a by 3 into under root of 41, option C 3a, and option D a times of root 3. This MCQ came in JEE Mains 2016 examination. Students, to solve this particular MCQ, we are going to use the basic formula for velocity of a particle which is performing simple harmonic motion. Students, the formula for velocity goes like this. V is equals to plus or minus omega into under root of a square minus x square. Omega denotes angular frequency. V denotes velocity of the particle performing linear SHM. Capital A denotes amplitude and X is displacement of the particle from the mean position. First of all, let me square this. When I square, I will be getting V square is equals to omega square the whole into A square minus X square. Students, we are going to use the same formula twice. First time for velocity v and second time for velocity 3 times of v. So first condition goes like this. V square is equals to omega square multiplied by a square minus of x square. And what is the value of x, students? Displacement from the mean position is 2a by 3. Yes, let's say this is our equation number 1. For second condition, students, the velocity is 3 times of v. So using the same formula, we'll be getting 3 times of v the whole square is equals to omega square multiplied by new amplitude square. Let's say, students, the new amplitude is equals to a dash, and that is our requirement over here. So this will be omega square the whole into a dash square minus of x square. And what is the value of x, students? It is 2a by 3. So we say x square will become 2a by 3 square. Let's say this is equation number 2. Now we are going to divide equation number 1 by equation number 2. When we do that, students, first of all, omega square will get cancelled and we will be getting v square divided by 3v the whole square. That will give us 9 times of v square. This is equals to a square minus of 2 by 3a the whole square will give us 4 by 9 times of a square. The whole upon, students, we say it is a dash square minus of 2a by 3 the whole square. That will give us 4 by 9 times of a square. So we get, students, v square divided by 9 times of v square is equals to a square minus of 4 by 9 times of a square the whole upon a dash square minus of 4 by 9 times of a square. So, students, v square will get cancelled and we are getting 1 divided by 9 is equals to a square minus of 4 by 9 times of a square will give us overall 5 by 9 times of a square. The whole upon a dash square minus of 4 by 9 times of a square. Doing cross multiplication now, students. A dash square minus of 4 by 9 times of a square. This will be equals to 5 times of a square. Simplifying further, we are getting a dash square will be equals to 5 times of a square plus of 4 by 9 times of a square. Using simple algebra, we are getting a dash square as it is, but that will be equals to 49 by 9 times of a square. Now taking square root of both sides, we get a dash will be equals to 7 by 3 times of a. So the new amplitude which we are considering a dash is equals to 7 by 3 times of a. So the correct answer is option A, 7 by 3 times of a.